Hello guys and welcome back. So now we're going to look at how we can process this and see what is the best way to add noise to it. Okay, so we talked about the volume VOP, so I'm gonna hit tab and type in volume VOP, and we can use this node to process the data here. So we have a density field. I'm gonna dive inside, and I'm gonna use it. It's this guy here. I'm gonna use this field, generate a new noise, and multiply it to change the density field. So let's create noise, and I'm going to use the position. It's a vector noise, and I'm going to use a multiply node and just change this. And now we added noise to the field. Now this guy goes between -1 and 1, and I'm going to simply clamp it, and that will remove the negative values. I'm going to increase them up, so the minimum is 0.2 and the maximum is 1. And let's increase the noise, set it to 10, 10, 10. Let's see. Okay. Yeah, the clamp was removing pretty much everything. Let's set it to 4, 4, and 4. And you can see now we're adding more noise. Let's increase this 10 times, and now we have more noise. Cool. So we changed the data quite a bit. We can, for example, create a sphere instead. And let's increase it, and maybe convert it into a polygon instead. And let's use a mountain node to add some noise to it. Something like that. And let's convert this into a volume instead of using the statue, and try to create some kind of cloud shape. So let's add the noise in, and this is our volume. But if we look closer, we see that it did not surpass the boundaries. The shape of the volume is still the same, it's just the value that changed. Okay, it's just the value inside these guys changed. Now let me try and explain this. So we have the domain, and so we have the domain like that. We have a z-axis, and we have one voxel. Okay, or you know what? Let me draw a rectangle. So this is our domain. And we have it like that. It's a 3D domain. Okay, and we have some data inside the volume. Let's say a sphere or a cloud. And this cloud is filling certain voxels. So we have voxels filling this entire domain all the way through, and only this part is filling the voxels with value of 1. Everything else is filling it with 0. And the way Houdini stores the data is by going over all the voxels and setting them whether they have a value of 1, a value of 0, a value of 0.5, and 0.2. So it's filling in the data here. When we changed the density, we took this information and we simply multiplied it with another noise. So whatever it was 1 here, we simply added noise to it. So we changed whatever existing in this domain. Everything else here that is with 0 values, we didn't change that, because when we multiply it with 1, it's gonna become 0. It's not gonna give us back anything. Okay, so in order for us to change the boundaries, we need to use something else. We need to use something called volume sample. And let's say we have a sphere that we converted into volume, and this is the domain, the front view of the domain. This sphere occupies specific voxels here. They have ID, and Houdini knows to fill only these guys. Okay. If we want to move the sphere inside the domain here, we cannot do that using the classic volume vol or use a transform node. We cannot do that like we do with points. We take the P position of the points, we add a positive value along the Z axis, and we can move the points. With the voxels, we cannot move that. We cannot move them. We have to use something else. We have to use something called volume sample. And what this does, let's say we have data here, like that, and Houdini is filling these guys with 1. This voxel, the way it displays the data, Houdini goes through each voxel and it samples whether it has data or not. Okay, so it goes here, I don't have data, no data, no data. Here I have data, so it displays 1. Here I have data, so it displays 1, or whatever value we have. For us to move this whole sampling data again to somewhere or noise it, we need to use a volume sample and shift the way Houdini samples these points. The voxels, sorry. We need to change the way it samples, or the order it samples the vector. The data, sorry. So let me illustrate this better. So here we're changing the density field. Let me lower this so it's faster to work with. And the bigger, the faster, and the less details we have, obviously. Okay, so what I'm going to do is let's go up. I'm gonna move this. Let me delete these guys. So we didn't change anything. Okay, and let's say I want to move this volume to the left or to the right or up and down. Let's say volume shaded wireframe. Okay, what we need to use is we need to use something called volume sample, and with this node we're gonna give it the point position, and we're gonna tell it where to sample from. I want to sample from the first input. I'm gonna change the signature to instead of primitive number to primitive name. Now these guys, when we look at them, they are ordered from 0, 1, 2, and all the way down as we have more primitives. To access this field, we can refer to it using the digit 0. We can access this one using 1. This method I don't like too much because the order can change easily, and I like to explicitly say the name of the field. So in this case, I want to sample from the first input a density called the field called density. If I plug this in, nothing happened, nothing changes. But if we create a constant and set it to a vector and add this vector as an offset to the point position, we're going to see the data moving through. It's not gonna go beyond the boundaries because that's where the domain ends. We're only working in this section here. So I'm moving the data left and right, and I can move it up or down as well by changing the point position. And you can see now we're going beyond the boundaries. We can go, and we're not limited to this only. So to break these boundaries, we can simply create a noise pattern, set it to 3D noise, and use that as an offset to where we sample the position. Okay, let's change this. Let's give it a value of 4, lower the frequency, 10. Cool. So you can see now, if we go back up, if we look here, you can see that this result is changing the boundaries of the data. Make sure I have this set. I'll talk about that later. So let's increase the density a bit. I'm gonna simply change it here by using a multiply node. So multiply by a constant, increase the density by 4, so it's easier to see. And now you can see we've broken up the silhouette. And what we did is instead of this voxel sampling that location, that specific location, we told it to sample this way, this point, for example. Instead of this guy sampling its current position, it samples from here. This one, for example, it's empty at the moment, so it should be 0, but we can move it to sample a different location that has a value, and that's how we get this interesting noise pattern. So this is basically how you create volumes or clouds in Houdini. So I'm going to copy this node, I'm going to add it here, and I want to add another layer of noise. I'm going to increase the frequency, and let's go back up and increase the resolution of the volume to look at the details we have. And there is no limit to what we can do now, because we can create data on the fly with this method. Okay, so the next thing I want to do is I'm gonna change the density field itself. I'm not gonna use the volume fob. I want to use the height of this domain, of this box, and clip the data that is below specific area. So what I'm going to do is I'm going to take the vector, the P position, actually let's lower the resolution so it's faster. I'm going to turn off the lighting because that adds to the overhead as well. So I'm going to take the P position, and instead of using this density and all this stuff, I'm going to just hide it, and you can see that it's only keeping the stuff at the top at the moment. So I'm going to use a fit range, and let's see, it goes between, I'm going to middle click here, between -8 and or -9 and 9. Sorry, -9 and 9. Okay, and now we have the data back. And I'm going to use this as a multiplier to my current data. Cool. I'm going to use a ramp here and tweak the ramp at the upper level. So let's go up. Let's play with the ramp. And right now it's changing, but not so much here, because the ramp is starting black here and white quickly. So we can use this to clip the data. Okay. And now we have, you know, those clouds with a flat bottom, and we can choose the transition as well, and we can make something like that. Okay, let's take a look at this with the full lighting, and now we have a flat bottom. Now to generate more clouds, or a quick way to, I'll explain this later. A quick way to generate variations is to simply add an offset here, say $F, and then run a sequence and save each frame to disk. We can increase the offset so it changes drastically between the frames, and this will give us a lot of variations of the cloud. Okay, now apart from doing post-processing or this, we can also use this volume data to fill in the space inside the object, and then use that to scatter points. So I'm going to use a VDB from Polygon, fill it with data. I'm going to tick on volume, fill interior. And what it does is this feature, it fills the data all the way in. And before, it was trying to optimize and be efficient about it, so it only stored the data around the shell of the object, but we don't want that. We want to fill everything. Okay, now it can scatter. Let's lower this to 0.4. It can scatter some points, and the great thing about this is the scatter node will work nicely with the volume. I'm gonna scatter 100 points, and then I'm gonna use that to and use a sphere and copy that sphere to those points. And let's change its type to polygon. I'm gonna use create a random attribute and call it p-scale, and this way we have something like that. Okay, and then we can take this VDB from polygon and this and noise up all these guys, and let's go a bit crazier, so something like that. Okay, more crazy volume, and now we converted that into an interesting cloud shape with just a couple of noises. Now let's increase the density after we multiply it. And what we can do right now, we're changing the density itself. I don't want generally to do that. I like to keep it so that I can see it in the viewport, but it doesn't have to be perfect. Okay, and I can go back to the lights themselves and tweak the lighting to see it better. Now I'm going to change this to distant light and set this to 2, and let's rotate it. Give it an orange tint, and then this is blue, so let's set it to distant as well, something like that. Let's change the viewport to flat shaded, and let's reduce this to 1.4. Cool. So let me think. So with this guy, I don't want to change the density value. Okay, I want to keep it as it is. What we can do to change the viewport display is use a node called volume visualization. And this guy, we can do various things. We can use extra fields and display them here, or we can just scale the density. And this is in the viewport only. It doesn't affect the data itself. Now, a cool feature of this is this max res, and it really depends on how much memory you have on your GPU. This is a very old graphic card I have, so we may not be able to handle this well, but I'm gonna go back to this node and let's increase the resolution to maybe have 800 on one of the axes for this case. And doing SOPs, working in SOPs with volume is much faster than doing it in Sims. So if we pushing it in SOPs here, pushing the resolution in SOPs does not have the same impact as doing it in Sims. Let's see how much we have. Okay, it looks good. And then with this system we can now batch generate multiple clouds and work on the noise and layer up different patterns and things like that, and hopefully we can create something interesting. Now there is a set of tools in Houdini, one called Cloud and one called Cloud Effects. I haven't used them personally. I always go and create my own from scratch, but maybe you guys can check them out. Now with this display, right now we're not displaying all the voxels at their highest resolution, and this is limited by default under texture, 3D texture. I don't want to unlock that. I want to leave that as it is. I'm gonna override it here just for this guy. See, the resolution already went low. I'm gonna increase it to 1024, and this is gonna try and display the entire volume in OpenGL. Now if you don't have a lot of memory, it can freeze Houdini, or you will see black stripes in the viewport. It means it cannot display or fit the data in memory in the GPU memory anymore. So this is the volume visualization. Cool. So I think that's pretty much it about the processing the volume in SOPs. Let's go. You can see we have tons of details. It's almost unmovable. It's hard to move in the viewport, but I think you guys got the idea. Now with this technique you can use, for example, to create atmospheric effects that don't move or move slightly, so you can just get by with animating the noise, for example. You can use it obviously to create clouds, and all this processing in SOPs is very, very important to prepare the data in DOPS, because let's say we have that character, for example, we want to convert it into volume and use it as a smoke emission to create an interesting sim out of it. So we're going to do that in the next video actually. So thank you for watching.